Somewhere between Mars and the Sun, an object from another star system is quietly passing through our cosmic neighborhood.
This object is called 3I/Atlas, and it did not originate anywhere near our solar system. Based on its path and speed, it may have formed around a star that no longer exists.
We are observing a traveler that survived multiple eras of the Milky Way itself.
Most comets remain dormant far from the Sun, frozen and inactive for centuries.
It released gas and vapor at distances where typical comets stay asleep.
That forces scientists to ask a simple but unsettling question. Why now?
Something is providing energy long before sunlight should be effective.
Then came the observation that made astronomers stop and look twice.
Perihelion was seen streaming forward, not behind the object.
This phenomenon is known as an antitail, and it is extremely rare. It contradicts what basic physics leads us to expect.
In decades of observation, few natural objects behave this way.
For a moment, the data did not fit the usual explanations. Then, just as suddenly, the behavior changed again.
The antitail weakened, and a traditional tail began to form.
It looked like a transition between two distinct phases.
Almost as if one process ended and another took over. At this point, caution becomes essential.
Nature often surprises us, especially when dealing with unfamiliar environments.
An interstellar object may behave unlike anything from our own solar system. Its chemistry alone suggests a very different birthplace.
Carbon dioxide appears unusually abundant compared to water.
That helps explain activity far from the Sun, but not everything. The timing of the changes remains difficult to ignore.
Why did the behavior shift at that specific distance?
We're modeling the rotation and heating scenarios now.
Look at the gas release data here. The sublimation rate is increasing exponentially as predicted.
Some models work partially, others fall short.
This is how science progresses, through tension between data and theory.
There is no rush to extraordinary conclusions.
Only careful observation, repeated again and again.
3I/Atlas also appears remarkably resilient for its age.
After billions of years, many comets would be fragile.
Yet this one remains intact and active.
One explanation is long dormancy in extreme cold.
Chemical processes slow almost to a halt near absolute zero.
In that state, Time leaves very little damage. Only when approaching a star does the object awaken.
That awakening can look dramatic to our instruments.
Another key moment is approaching rapidly.
On October 29th, it reaches its closest point to the Sun.
During this passage, heating will increase dramatically.
The tail may grow longer, brighter, and more complex.
Then the object will disappear behind the Sun from our view. For weeks, we will be unable to observe it directly. This hidden interval is scientifically frustrating.
Anything could happen during that time.
When it reappears in early November, comparison begins.
Scientists will measure brightness, shape, and chemistry again.
The most important test will be its trajectory.
Gravity allows precise predictions of where it should go.
Any unexplained deviation would demand attention.
But large discrepancies would be difficult to dismiss.
For now, the most likely explanation remains natural.
A relic from an ancient star system, behaving in unfamiliar ways.
Even that alone makes it scientifically priceless.
It carries chemical information from a time before our sun existed.
A message preserved not in language, but in matter.
Moments like this remind us how little we truly know.
The universe often teaches through exceptions, not rules.
3I/Atlas is one of those exceptions.
Whether comet or something stranger, it deserves patience.
Science advances by resisting easy answers.
And by allowing curiosity to stay open a little longer. For now, the data continues to arrive, quietly.
Telescopes watch, models update, and debates continue. Somewhere between Mars and the Sun, the story continues unfolding.
Not revealing its secrets all at once.
Reminding us that the universe always keeps something in reserve.
In physics, the most troubling question is not what happens, but why expectations quietly fail.
With 3I/Atlas, that question begins with momentum. Momentum is simple. Push material one way, and motion responds the other way.
In space, there is no friction to hide this effect.
So when something ejects mass, its path should noticeably change.
That expectation works for rockets, comets, even drifting debris.
Now imagine an object releasing material steadily over time.
Physics predicts its course should slowly curve.
But when astronomers tracked 3I/Atlas, that curve was missing.
Despite active outgassing, its trajectory remained unusually stable.
This stability is not impossible, but it is unexpected.
It suggests forces somehow canceling each other out.
Nature can do this, but rarely so neatly.
Especially in an interstellar object we barely understand.
Then, just as questions mounted, the behavior changed again. The forward-facing plume began to fade.
For a moment, the data went quiet.
And then, a traditional tail appeared behind the object.
This was not a gradual blend, but a clear transition.
Engineers would recognize this pattern immediately.
It resembles the end of a braking phase.
When thrust stops, motion becomes smoother and quieter.
Of course, resemblance is not proof. Space often imitates design without intention. But timing matters as much as shape.
This change occurred at a very specific distance from the Sun.
Close enough for sunlight to matter, but not dominate.
That narrow window raises careful eyebrows.
And then there is the nickel.
Nickel itself is common across the universe. But the detected form is not ordinary nickel.
It appears bonded in a way we usually manufacture.
On Earth, such alloys handle heat and stress. Comets, we do not expect them.
So far, no natural model fully explains this signature.
That does not mean nature cannot surprise us.
It means our understanding may still be incomplete.
Each anomaly alone might be dismissed.
Together, they demand patience and attention.
Stable motion, behavioral transition, unusual materials.
None prove intent.
but none vanish either.
Science advances by resisting both panic and comfort.
The correct response is careful observation.
Measure again, then again.
Check assumptions before rewriting conclusions.
Three-Eye Atlas forces us into that discipline.
It does not shout answers.
It simply behaves in ways we did not predict.
And that is where discovery often begins.
Whether comet or something more complex.
The data deserves respect, not dismissal. Extraordinary claims require extraordinary care.
Right now, care is exactly what scientists are applying.
Because rushing to certainty is how errors are born. The universe rarely rewards haste. Instead, it rewards those who wait and compare.
Three-Eye/Atlas is still writing its story.
Each new observation adds a line.
Some lines fit, others resist.
That resistance is meaningful.
It tells us where to look closer.
And where our models may be thin.
For now, conclusions remain open. That openness is not weakness.
It is how science stays honest.
Especially when something refuses to behave normally.
Three-Eye/Atlas does not break physics.
It simply tests how well we understand them.
And sometimes, that test is the real discovery.
The universe is not hiding answers, only timing them.
In space science, age usually means fragility, especially after billions of years of constant exposure.
Cosmic radiation never rests, slowly eroding everything it touches.
Interstellar dust may be tiny, but over time, it acts like sandpaper.
Most ancient comets should be cracked, weakened, and unstable.
That expectation makes Three-Eye/Atlas immediately stand out.
Despite its age, it remains structurally coherent.
Even more surprising, its activity appears organized, not chaotic.
This is not how fragile objects usually behave.
One explanation is extreme dormancy in deep interstellar cold.
At such temperatures, chemical reactions almost completely stop.
In that state, time causes surprisingly little damage.
Only when approaching a star does the object truly awaken.
Awakening usually brings stress, fractures, and unpredictable behavior.
Yet 3I/Atlas responds in measured stages.
That level of control challenges our expectations.
Then comes another intriguing detail: cyanide.
Cyanide compounds are not rare in space.
They appear in comets, asteroids, and interstellar clouds.
But here, cyanide appears unusually concentrated and stable.
Stability over time is what draws attention.
This suggests more than random release.
In engineering, such molecules can regulate energy flow.
Could chemistry influence behavior at this scale?
It is a question, not a conclusion.
Still, chemistry and motion seem unusually connected here.
All of this leads toward a critical moment.
Perihelion, the closest approach to the Sun.
This is when heating reaches its maximum.
It is also when observation becomes impossible.
From Earth, the Sun blocks our view completely.
Scientists call this the blind window.
During this time, anything could change.
Orientation, rotation, even velocity may shift subtly. These changes would leave no immediate trace.
Only later would differences appear.
This makes perihelion scientifically risky.
Models predict what should happen next.
Reality will reveal whether those models hold.
If they align, confidence grows.
If they differ, questions deepen.
This is how science tests itself.
By comparing expectation and outcome.
3I/Atlas offers a rare opportunity.
Few interstellar visitors stay observable this long.
Fewer still behave so consistently. Structural strength, chemical stability, timed transitions.
None alone are extraordinary.
Together, they demand careful attention. Science moves slowly for a reason.
Rushing answers often creates mistakes.
Patience allows patterns to emerge. 3I/Atlas does not explain itself.
It simply behaves, and we observe.
That behavior tests what we think we know. Especially about ancient objects. Objects older than our sun. Carrying chemistry from another era. Preserved by cold and distance.
Now briefly warmed, briefly revealed.
And soon hidden again. When it returns, comparison begins. Numbers before and after will matter.
Small differences may carry large meaning.
We avoid excitement here. Only absolute focus will ensure the timing is perfect.
Not speculation, but measurement.
The universe rarely speaks loudly.
It prefers subtle clues.
Atlas may be one of them.
And understanding it will take time.
One detail about 3I/Atlas quietly caught the attention of planetary defense experts. Not because it threatens Earth, but because it might teach us something rare.
The International Asteroid Warning Network does not react lightly.
Their focus is usually danger, not curiosity.
Yet 3I/Atlas drew their attention anyway.
That choice carries a lesson learned the hard way. In 2017, Oumuamua appeared without warning. It came quickly, and it left even faster. Telescopes barely had time to react. What followed were years of debate and missing data. Oumuamua showed no visible tail.
Yet it accelerated as it departed the sun.
Physics allowed explanations, but none felt fully satisfying.
Many female African American scientists later admitted we missed a critical opportunity.
That memory still lingers.
So when 3I/Atlas appeared, the response changed.
This time, no one wanted to look away.
Because unlike Oumuamua, this visitor stayed visible. It gave scientists time, something rarely offered.
Time to observe, compare, and question.
That alone makes 3I/Atlas valuable. But context matters, especially with interstellar visitors. So far, we have met 3. And none of them behave the same way. Oumuamua was strange and silent. Borisov was comforting in its normality.
It behaved exactly as textbooks predicted.
Many scientists felt relief watching Borisov.
Then came 3I/Atlas. Not extreme in one way, but puzzling in many. Early activity far from the sun.
Behavior that changes in stages.
Chemistry that feels unfamiliar.
And enough time to watch it all unfold. Taken together, this pattern does not alarm me.
It intrigues me.
Because diversity challenges simple models.
It suggests interstellar space may be full of surprises.
And that leads to an important clarification.
This is not about aliens.
That question is tempting, but not central.
The real question is more uncomfortable.
Are we stretching natural physics too far?
Not to explain data, but to avoid discomfort.
Science prefers natural explanations, and rightly so.
But preference can quietly become bias.
When every anomaly needs a special exception.
It is fair to pause and reassess.
That pause is not failure.
It is discipline. This is why IAWN pays attention.
Not to declare answers, but to preserve questions.
They remember what happens when we rush.
And what happens when we wait?
Three Eye/Atlas offers that second chance.
It allows careful measurement instead of guesswork.
Comparison instead of speculation.
And humility instead of certainty.
If natural physics explains everything, that is progress.
If not, that is progress too.
Either way, we learn something essential.
Drifting silently from other star systems, these cloaked objects remind us of the vast mysteries of the cosmos.
About our assumptions. And about how science should respond to the unknown.
Not with fear.
But with patience and attention.
Because the universe rarely repeats itself. And missed chances rarely return.
This time, we are watching.
Carefully. And without rushing to decide what it must be.
For 60 years, SETI has listened for radio whispers from the stars.
We assumed intelligence would announce itself by broadcasting signals.
That assumption made sense, based on our own technology.
But assumptions can quietly limit what we're prepared to find.
Have you ever wondered what survives longer, signals or objects?
Signals weaken, scatter, and vanish with time.
Objects, however, can persist for billions of years.
A long-lived civilization might leave artifacts, not broadcasts.
Possibility rarely guided early searches.
SETI was not wrong, just narrowly focused.
We searched for voices, not footprints.
And footprints often appear before encounters.
This is why interstellar objects matter so much. Even if completely natural, they carry unique information.
Consider 3I/Atlas as a simple comet.
its chemistry formed far beyond our solar system.
That chemistry records conditions we can never recreate. In that sense, it is a flying museum. A preserved sample of the early galaxy.
We cannot touch it or bring it home.
But light alone can tell remarkable stories.
In the beginning, there was only dust and gas swirling in the cosmic dark. But gravity,
even as a comet, its value is immense. But let's ask a harder question.
What if it is not a comet?
This does not imply invasion or intent. There is no approach, no message, no threat.
If artificial, it would be something quieter.
More like a footprint than a visitor. Footprints appear long after the walker is gone.
They tell us someone passed this way. Not who they were or why.
Human history works the same way.
Objects often outlive their creators, ruins enduring long after civilizations fade.
in space, that effect is magnified.
Artifacts could survive when signals cannot.
That changes how we should search.
It asks us to broaden our thinking.
SETI's greatest limitation may have been perspective.
Intelligence does not owe us familiarity.
The universe rarely meets expectations.
Three-eyed/Atlas invites that realization.
Whether comet or artifact, it teaches humility.
It reminds us we are late arrivals.
Others may have come and gone. Leaving only matter behind.
Science must be ready for that possibility.
Not to believe, but to observe carefully.
Evidence begins with patience. And patience begins with open questions.
Three-eye/Atlas does not demand conclusions.
It demands attention.
Attention to what survives longest. Attention to what history leaves behind. SETI may need to evolve.
From listening to noticing.
From signals to substance. Most of them are quiet.
Yet it carries deep implications.
Across the timelines, intelligence seeks to understand its place, navigating the vast currents of time towards an uncertain future.
And about our place in the story.
We may not be the first readers.
Or the intended audience.
But we are careful observers. Learning to recognize traces.
Rather than waiting for greetings.
In science, that shift matters.
Because footprints often change history.
Long before meetings ever happen.
And sometimes, they are all we ever find.
November will not deliver a final answer about 3I/Atlas, and that may be the most important result of all.
Science rarely reveals truth in a single moment, especially when something truly unfamiliar appears. We often expect a dramatic reveal, but discovery usually arrives quietly. Imagine standing on Mars, watching Earth as a faint blue dot through primitive optics.
You would not understand oceans or life from one glance alone.
Understanding comes from patience, repetition, and comparison over time.
That is exactly what November represents for 3I/Atlas. Not revelation, but measurement.
Not answers, but tests.
We will compare before and after, expectation and reality.
If familiar physics holds, that is valuable knowledge.
It tells us our tools still work in extreme cases.
But if small differences appear, that matters just as much. Major shifts in science often begin with tiny mismatches. History shews that progress rarely announces itself loudly. Sometimes it simply suggests our models need refinement.
If November tells us to think more carefully, that alone is a success.
I want to speak now, as someone who has watched the universe for decades.
I am not saying this object is a spacecraft.
I am not claiming evidence of extraterrestrial technology.
Those conclusions require far more proof than we currently have.
Scientific caution is not weakness, it is discipline.
Most of my career involved objects that behaved exactly as expected.
Stars burn, planets orbit, and equations usually agree.
Even black holes follow strict mathematical rules.
But every so often, something behaves just slightly differently. Not wrong enough to dismiss, not neat enough to ignore.
3I/Atlas belongs to that rare category.
It simply behaves in ways we did not fully anticipate.
And those quiet differences are often the most important. Have you ever wondered why discoveries take decades to be accepted?
Because humans notice what fits expectations first.
Subtle anomalies are easy to overlook. And the universe rarely speaks loudly.
If 3I/Atlas is only an unusual interstellar comet, that is still meaningful.
It would expand our understanding of ancient cosmic chemistry.
It would refine how we model objects older than our sun.
That alone would be a significant scientific contribution.
And if it represents something beyond our current frameworks.
November will not confirm that either. Such conclusions never arrive all at once. Many observations stacking slowly over time.
That emerge through years of careful comparison and debate.
So patience matters more than excitement right now.
Science is not about absolute certainty.
It is about knowing what we know and what we do not.
And sometimes realizing there are questions we have not yet imagined.
In moments like this, restraint is wisdom.
Listening becomes more important than speaking.
Observing becomes more important than declaring.
I am not saying this is a spacecraft.
I wish that the universe may be whispering. And whispers require attention, not noise.
Rarely do we get moments like this.
Moments where restraint is the correct response.
Where curiosity must outrun certainty.
where observation comes before interpretation.
November is part of that process, not its conclusion.
The real story will take time to unfold.
And time is something the universe always demands.
Three Eye/Atlas is not asking us to believe.
It is asking us to watch carefully.
To measure honestly.
To question gently.
And to remain comfortable with uncertainty.
That discomfort is where science grows. Loud answers often fade quickly.
Quiet questions tend to last. A persistent glow remaining after others fade. This is one of those quiet moments. Not deciding too soon.
Not forcing conclusions.
Simply listening to what the universe allows us to hear.